Okay. Good morning. Good morning to all. So today we have been discussing on this concept in the previous class, like device design. As you all know that IoT, when you design a device, it is very important to know many parameters. So each parameter plays a major role, and we should know that how the size of the component has to be, what is the energy consumption, then how is the input output device we have to set. All those things it is very important for us to understand. So we have to know that when you are considering any design setup based on your application, sometimes size might not be a concern for you. When you are taking some application, size may not be a major concern for you, but in some applications, size may be a key concern for you. You cannot have a very big devices and all those things for your entire process. So this is very important. So we need to know that each parameter, its role, and how it is going to impact when you are going to go with the design process. Some of the parameters we have already discussed, like size. It's a key factor with respect to when you are taking, you cannot have a very big, huge size device, because sometimes it will, when it is a huge device, what will impact? It will create the energy consumption will be more. You cannot deploy it in a proper way. All those problems will come. So you have to make sure that the size of the device has to be optimum. Okay, so that's why we have to have the form factor, and we have to large form factor is not suitable for sufficient bulk IoT application. So based on the application, you have to make sure that all these things are taken care with respect to size. This was one which we studied in the last class. What is the next parameter? Energy. So energy is a very critical parameter when you talk about any node, and you know that when you are deploying it in a very remote places and all, you have to make sure that the durability or the device has to be there for a longer duration, so that you have to make sure that the optimization of energy consumption by that node setup is very important. So we have to design in such a way that higher the energy requirement, the source replacement of battery and all those things takes place, which is not user convenient. So you just imagine that very frequently you are going and recharging the load. So that is not that efficient. So when you are placing the node or deploying the nodes in very remote areas and all, you have to make sure that you take care of consumption of energy of that device. You make sure that the device consumes the minimum energy. So we will see that. So consumption of energy is a major concern when you go with respect to nodes, and the cost. You know that when you are designing a node, cost plays a major role, because you will not be designing or deploying a single node. For example, you have done some mini projects and all. You are doing a small setup. You are doing it in such a way that it should be used in multiple places. It should be utilized in different places. When you are now you are for example the project what you are developing, it's very huge, and it is not able to withstand the energy. It is consuming more energy, and as well as the cost of production is also very huge. Then whether you think the users will go for it? No. So that is why when you are going for the design, you have to keep in mind that your cost of consumption should be less, your energy consumption should be less, and as well as the size of the component as small as possible. You can really you have to optimize all these parameters, so it plays a major role in the design process. So cheaper doesn't mean that you just use very low quality devices and all those things. You have to see that which quality is required for the application. If you cannot compromise the quality when you are going for a high rate processing and all those things. You may have to see all those things, and you have to come out with a clear picture that whether it is required for you or not required for you. That is called as analysis. You have to have a clear analysis of what is required based on the application. Whether, say for example, you are going for an agriculture application, the requirement will be different. You are going for a military application, the requirement will be different. You are going for a healthcare application, the requirement will be different. Some cases you can compromise the cost, some cases you cannot compromise the quality. So cost will be sometimes it will be high only, but in that also you can select in such a way that you can select the optimum components which is available in the market in such a way that if it is costing you 10,000, you can at least bring down to 7,000. So you are having a optimum margin of 3,000, and when you deploy it for a huge area, you are going to get almost 3 crores or 4 crores. That much difference is going to create when it is a minute difference what you are going to create for one node. Okay, so that is why cost plays a major role, and each company which manufactures all these devices look into all these factors. Then what we have seen, memory. So some cases you need to have a sufficient memory capacity for that nodes. All those things, processing speed, high memory means if you go for too much of memory, which is not required for that node, node is not going to use that much of memory, but you are still having it. That is not going to be good, because see, you need some memory capacity, but you are giving for that node 3 times extra memory, which is of no use for that. So while that two portions of that memory, what cost you are investing for that node is waste. That energy consumption, whatever it is happening extra for that part of the hardware, it is all not useful for you. So based on the application, you should decide that what is required for you and what is not required for you. If it is with respect to processing power, also the same case. You need a very high-end processor, you should go for it. Because if the application demands a high-end processor, you cannot just say that the cost is high or the size is different and all those things. So based on your application, you need to find out that what is required for you. So you should say that these are the requirements for your application. These are the requirements which can be compromised. So you come across a certain conclusion. So it's very important for anyone to design a very sophisticated hardware rather than simply coming and placing the hardware and without any proper knowledge. So it is very important for us to have a clear indication what is required, what is not required, how much you have to invest for this, how much you don't have to invest, how much capacity it can withstand, how much it is not able to withstand, whether it is sufficient for this application or not, or you need to have more processing speed or not. So all those complete process you need to understand, and it depends on the different types of application. So some applications may demand for you a high processing speed. Some applications may demand for you a low processing speed. Where low processing speed is there, you don't have to keep a very high processor, because you are directly increasing the cost of the node and all those things. Then where it is high processing is there, you cannot go and keep a low processing speed, because your entire application will fail, because you are not able to match the requirement of the user. So all those things you have to consider, and you have to come to a optimized figure. Optimized figure means you need to make sure that okay, cost is this much, energy consumption is so much, memory capacity is so much, processing speed is so much. So when you put together, you come to a node or the device, IoT device, which can withstand all the process. See, now you have different font in your hand, isn't it? You have different types of fonts in your hand. You see that each is different from one another with different features. Correct. You don't need too much of processing speed, and you take a very high processing speed for you. It is not going to be useful for you. You are not utilizing all the features properly. So what is required for you, you go for that. So the design process is very important. Okay, these things we have done in the last class. I think we are left out with IO rating. So what is IO rating? So what are things input output rating? So it is very important that how the device communicates with the input devices as well as with the output devices. So you can say that preliminary processor factor determining the complexity of the circuit, energy usage, all those things plays a major role. Then IoT rating, it is 3.3 volts and compared to 5 volts, whatever ratings you design for the entire hardware module, and requiring additional voltage of logic conversion circuitry, all those things, whichever you are interfacing with the see, you will manufacture a device, and you may have to interface some of the hardware and all around in that. For example, you have your mobile phone, but still you connect a stereo along with that, or you connect some other devices along with that. So you are having a interface between the devices as well. So you need to make sure that despite low power consumption due to reduced IO voltage levels, so still you have to make sure that there is no power reduction and all so much. Okay, so that is one thing. The next one is add-ons. Add-ons is very much familiar with you. What is add-ons? Additional features. Additional features, whatever it is required. So it is not, see, you just manufacture a basic device, and you have add-ons to that. So why you need you have a basic device and you add some things to that. For example, can you say some examples like, say you purchase a laptop, but the laptop may not have a very high stereo capacity and all those things. So you add a very high stereo capacity to that. It becomes an add-on for that. Okay. Now you may not have very much high-end display and all. So you connect to a very high-end TV which has a better display and you can work on it. It becomes an add-on to that device. So you can have any add-ons based on your applications. Here you can say analog to digital conversion units. If it is required, you can add to that. Then clock circuits you can add to that. Connections to USB you can do Ethernet. Then wireless accessibility. All those things can be considered as add-ons based on your requirement. It doesn't mean that it's required for all the applications. Some of the applications doesn't need any connectivity. So some of the applications need some USB connectivity. So all those things you can add. Add-ons also decides how fast the solutions can be deployed and interfacing and integration systems, all these things. So you can also see that you may have if you are taking any device, you know that sometimes they say that this much is only the ability of this device to withstand. If you are adding some component to it, it has the capacity of having this much extension only. Beyond to that, your device will not support. So all those process, everything will be predefined. So one more thing I want to say to you is, before doing, we have studied all these features. Before doing any component selection, let me see that you have done some of the other mini projects. You have selected different components. You might have done whether you have done a market survey on these components. For example, let me take a very simple example: temperature sensor. Okay, there are hundreds of temperature sensors available in the market. So have you done a clear survey on which sensor to select, why to select that, why not to select the other sensors, what is the key features of that sensors? Have you done a market survey on that? Whether the cost is good, cost is high, cost how you can reduce, what is the best cost efficient sensor available in the market? You have to do all those sensors, means all the survey. Then you select one sensor. And for example, you are selecting a temperature sensor, you also have to go through the data sheet. Have you all gone through the data sheet? Have you seen the data sheet of any of the devices whichever you have selected? Which pin to which connection, why this connection is done, what are the features for this, what is the memory capacity if you are going for any processor and all, how much it can withstand, why you select this processor, why not another processor. All those study you have to do, that is called as design. That is called as design. Design means understand what is available and choose the best available for you in the project. I think this stage you might have not done to that level in this assignment 1, but for the assignment 2 you go through each component data sheet and learn all the features of that device. You compare the data sheet of this device with another device, same device data sheet. See that what features are there for this, what features are not there for this. You do know when you select a mobile phone, you see entire specifications of that, you do review of customers, you do all those things, right? Then only you go for the device. If you go to the shop and buy one phone and come, no. Similarly, you have when you are selecting a component also you have to make sure that you do the entire study of why you are selecting this component, what are the key features of this, why this component, why not another component. All those things comes under the design. What is the energy consumption, whether it will support the input output devices, how many devices it can support. You have some of you have done Arduino based projects and all. So how many devices it can support, what is the memory capacity, what are the features for that. Have you gone through the data sheet? Please go through the data sheet, then only it will give you the clear indication whether this is the right component you have selected for the right application. Okay. So all those things is very important. So we have discussed all these parameters. So what are the parameters we have discussed? Size, energy, cost, memory, processing speed, processing laser processor, which we have studied with respect to IoT devices. Is that clear for you? So while going through any design process, you have to go in detail and understand each device, what is its functionality, what for it is, why it is required, to what extent it can serve for your application. Available in the market which can serve better than this. All those the survey has to be done. Then you select it, then you go and get that device. So there are many websites also where you can do a comparative analysis, comparative study, comparison of the components. How many of you have seen the data sheet for any of the one component? Why by the RAM? Okay, very good. So go through that. Okay, one more question I will ask. One simple question. How many of you know the detailed features of your mobile phone? What you are using? You know? I will ask you questions. You should answer for that if you know. Which is the processor? So as raising hand, be careful. So you have not seen the detailed specifications of your mobile phone itself. Then notice that you are carrying different devices. So please go to that specifications of the devices what you have. So I will give you a very simple. Let us have a very simple assignment, not for just for and fun. So the assignment is you have to find out what is the which is the processor in your mobile phone, what is the speed of the processor, what is the memory capacity, all those things. And one more question is which is the company which has manufactured that? To find out can come. Okay, fine. Let's go for the next one. So the last topic of this module, so that is processing offloading. So the last topic of this module is processing offloading. So we will be studying here. So processing offloading is very important in deployment of densely deployed. We know that we have to deploy the nodes. Deploy the nodes means what? For example, you are measuring where you want to deploy the nodes. Let me have an example from your end. Okay, let us see that very remote place where human interaction is not there, and you need to know that whether the climatic conditions are all fine there, or is there any terrorist attack there, or any terrorist movement is there, or all those kind of things. You have deployed some 100 nodes there. Okay, so if any small movement is there, you are going to get the intimation that there is a movement here. If there is anything, any problems, you are going to get. You have deployed the sensors according to that. So you have to make sure that you are deploying the sensors. You need to make sure that the energy consumption is less there, because you cannot keep going there and keep on changing the sensors there. Okay, means you cannot. And miniaturization. So you have to make sure that the cost of the means the component is not too big that anybody can track it. So it should be small. Then cheap IoT based solutions and sensing. Then IoT deployment is a various layers of processing is there from the near as a sensing environment and far as cloud based environment. So you have seen two things. One is offsite and On site, you have seen in that also too. What are those? I have told you to study everything. What are those? So, starting from the preliminary layer of sensing, we can have multiple sensing types, that is fire, surveillance, and all those activities, whatever we can go on to measure. And the sensor enables the sensing types and integrating processor into usage. It can be wired as well as wireless. So some applications you may go for wired, some applications you may go for wireless. Also, you can see that application requires immediate processing. Some of the data has to be transmitted immediately. So immediate processing is required and sends the data on site processing topology. So these are some of the points which you can see. One figure we will see in the next slide. So almost basic we have already. So you can take down few cross points and we will move on to the next slide. Okay, you have, we'll go for the next slide. See, we have seen different applications in the same module with respect to fire, surveillance and all. So we'll see that. So here you can see, so the various data generation and storage process you can see here, where the sources are connected to the internet and data types are obtained within it. Okay, so what you can see here, this is the application, like this is the process where some places if there is a chance of a fire or surveillance. Surveillance means you don't know with the help of camera and all you monitor the entire remote places. So whether it is a surveillance or a thing, you need the first stage is what? You will be having on-site process. In on-site process, you have sensing and local processing. In that, you have different sensors like it can be a temperature sensor, it can be a temperature sensor, it can be a camera for surveillance and all. Then you have all these things. Then you have a local processor. This is the sensor node. Then edge processing, you'll be having the connectivity, that is the local network connection, one node connected to another node connected. So it will be a connection of different nodes together. Then that data will go to the hope processing. Hope can see what are the internet servers and database. All these things it will be processing. And then further what will happen? That information will be further carried on to the cloud processing where it will be going to a bigger system where the servers and you can see database, all those things will be taken care. So you can have here, you can have a wired or wireless process of communication here. Then you will be having a short range of process and then long range of wireless communication. So that is what the entire process is, a long range communication. So what it is going to do? You measure the information with the help of sensors, and then with the nodes you transmit it, and it goes to the fog processing as well as cloud processing, wherein the servers and database and all it will store your information as well as it will process your information for further nodes. So this is the entire here, where you can see the data generation and storage of sources connected to the internet. So this is how the entire flow of information takes place. So this side you can see how the communication process takes place. This is the sensing and processing. So you need to practice this figure later. You can draw these figures. So what is the next one? So some of the IoT applications what we have seen, like processing is to be carried out remotely, and the same figure what we have discussed before, where on-site devices simple and small, it should be economical, and off-site processing of data, you can say that sensing layer, forwarding and fog, cloud, and all those processes what we have seen in the figure previously. So you can see that all this contribute for the communication process. Then edge layer makes the use of devices and local network process the data to the collaborative processing topology. We have seen the collaborative processing topology in the last session, previous session. Yes or no? So one of the collaborative and one more what we have seen is, what is that? Two things we have seen offset. So remote processing and collaborative processing. So you can say that the data needs to be sent further up in the cloud, and long range of wireless communication can be processed. Then fog-based processing can also be done for geographical areas of where IoT devices are located. So then in fog level communication, what are things you can see the gateways, then you can see its way of priority access and IoT devices which can be connected to the internet or for the transmission. So we'll be seeing these things you can take down later. Then this one more slide we will do it for today. So what are when you are forwarding the data to a cloud or remote server, the devices has to be connected to the internet, and which helps in the long range of data communication. For example, you are transmitting this data from here to a longer duration. So you can go for long range communication when you are connected to an internet, and this is costly considering the bandwidth. When you are considering the bandwidth, latency, as well as the complexity of the devices, the network infrastructure will be slightly complicated, because you have to always consider that your latency should be low, and your bandwidth should be available, and your cost also should be comparatively less as much as possible. Okay. So when you are going for a wireless long range communication, you have to make sure that all these devices support for your communication process. So then you have data uploading is divided into three categories. So all these three categories we will be studying in detail in the next class. What are the first one? What is the first one? Offload location. Offload location means what? Processing can be offered in the IoT architecture, which where you have to deploy, which kind of thing. If it is a very much, you also have to make sure that when you are deploying the rules, you have to see the climatic condition or that place how it is. If it is completely rainy, some of the parameters you have to consider when your device is designed. If it is completely sunny, cannot, it has to withstand above 50 degrees centigrade and come. So you have to make sure that all those parameters has to be. So we'll be seeing all those things where the processing can be offloaded in the IoT architecture. The second one is what? Offload decision making. So where to offload the processing to the and how much. So you have to make sure that while making a decision, what are the parameters you need to consider and whether these parameters you have fulfilled when you are designing the entire device or not. Then the last one is of offloading considerations. So you have to make the decision when to offload or what are the features when you have to consider while you are going for a offload. So these are the three things which we are going to study in detail in the next class. Okay. So that is offload location, offload decision making, and offload consideration. So you can note down those things. You can just note down those things. We'll stop it for today.